All right. Hello, I'm Max Johnny Twist, and this is my presentation, Trivialising the Impossible, Package Management with a Small Team. For those of you with bad short-term memory, that's my name again. My GitHub, my website, Chromebrew, which we'll be talking about today, Ruocop Crystal, which is going to be big, and then GCJ, which was big, and then I had to go to year 11. So those are some of my projects. So Chromebrew, which I'll get into more deal about what exactly this means later, but for now, it'll suffice to say that it's a package manager for Chrome OS. My personal involvement with Chromebrew dates back to March 2022, when I added the package because I wanted to install it on what was at the time my school Chromebook. I like the team, I like the code base, and I've been working on it ever since. Speaking of, here's the team. That's me again. I'm an Australian university student, for those of you who didn't gather. That is Satdar Pramanik, Sat Mandu, he's a doctor in New York. Ed Real, Uber hacker, programmer in Texas. Subi Chicken is a Hong Kong high schooler. We don't know his real name. So, introduction. We're going to go over what is package management, what is a package, a brief technical overview of package formats, management backends, and then the languages you write them in, and then just solving problems, package file formats, adding a package, updating a package, fixing a package. Okay, what is package management? It's managing packages. Thank you all for coming. No, package management is installing packages. This often involves building the package, and then ideally you do want the package to work. It's a big thing there. Everything else in package management stems from this. So dependency management, configuration options, security patches, bug fixes, it all comes down to installing a functional package. So everyone is a package manager. Linux, APT, RPM, APK, Nix, Pacman, MOS, Portage, ERPTG. macOS has Brew or Homebrew or Mac ports. Even Windows has some. It is Chocolatey, it is Winget, it is Scoop. Some languages even have one too. So Ruby has Gem, Rust has Cargo, JavaScript is NPM or Yarn or PNPM or Bun or Berry, which is just Yarn again. Python, you got so many with Python. You got Pip, UV, Poetry, Hatch, PDM, Kana, Minikana, Mamba, Pixie. There's more. I couldn't fit them all on there. But Python, many package managers. Everything is a package. Top right, packages for Grub, 525. That's your bootloader. Your bootloader is a package. A Linux distribution is just a collection of packages. You can change an Ubuntu installation to a Debian installation by changing the sources and then just APT upgrade. I know it was in my CI for some reasons. This is because derivative distributions are just package modifications. You hear Fedora-based, Arch-based, Debian-based. That's because they take Debian packages, Debian's package manager, and then add their own packages. Now, not all operating systems are like this in the sense that they are just all packages. So Chrome OS and Mac OS, they have bits of the system that are not installed by a package manager. And then you do have certain toy operating systems like Linux from scratch or Windows that really aren't designed for package managers at all. They're not very practical. No one uses them. What is a package? So earlier, I said that everything is a package. That's not really helpful. From a user's perspective, what a package is more of a philosophical question. But for a package manager, a package is a collection of information. Most important is the information required to install a package, which we went over earlier. Is part of package management, but this does get surprisingly complex. And then you do want metadata. So, your version, your homepage, your license, your name. It's actually a big one. Most package managers do include the name as part of the metadata. So, a technical overview. Remember that a package manager is not just a collection of package files, but it's also the tools required to build and install the packages. You can subdivide this further. You can split them into a front end or a back end, APT and DPTG. You can have multiple sources of package files, Ubuntu PPAs, Brew tasks, and then you can have precompiled binaries, which is basically everything but Gentoo, although they do precompiled binaries now. And there's more, but for today, we're just going to focus on the tools and the package files, a brief outline of the problems they face, and comparing different approaches to solving them. Package files. Earlier, I said the packages were collections of information. This information can effectively be divided up into two types, both of which present their own unique challenges. Static information, name, version, license, homepage, dependencies. Instructional information, build instructions, install script, configuration options, remove script. This creates a problem. So data formats well suited to holding instructional information or static information like JSON or XML or YAML TOML, they're not well suited for holding instructional information. You don't often hear about a install.json file for good reason. And likewise, options suited to holding and executing instructional information, like a shell script, they're not that well suited for holding static information. You don't really have any bash-based databases. And then management backend. So a package manager backend needs to be able to parse both of these kinds of information and then execute the instructional and variety in order to build or install packages. And beyond that, it does need to be able to, query and interact seamlessly with the system, manage complex file and network operations, and then you want it to be as robust and self-contained as possible. If your package manager has a lot of dependencies, you can't install the dependencies at the package manager, and the bootstrapping, it's no good. So a package manager needs to be able to store metadata, store instructions, parse and act upon metadata, and then parse and execute instructions. So as a result, most package managers will use different languages for different tasks, and this has a benefit of enabling despecialization. Or some package managers create their own custom language, like NixOS, which in a sense trivializes this because your language can be whatever you want it to be. But so here are some distributions, their backend, metadata, instructions. Just a quick overview. Gentoo, the backend is Python. Metadata instructions are in the custom ebuild file format. Arch, backend is C. Metadata and instructions are in Bash. FreeBSD, backend is C. Metadata instructions are in Makefiles. NixOS, backend is C++. Metadata and instructions are in Nix. Fedora, backend is C++. Metadata instructions, custom RPM spec. Debian, the backend is in C++. The metadata is in the custom control file and some other things. And the instructions are in Make. The VCPKG, the metadata, the backend is in C++. Metadata is in JSON, and the instructions are in CMake. Yay! CMake. Chocolatey, the backend is C#. The metadata is XML, and the instructions are in PowerShell. Some of you may remember that Chocolatey is Windows-based. Could you tell? Distribution, Glaucus. The backend is in NIM, which isn't real. The metadata is in TOML, and the instructions are in POSIX-compatible shell. But this isn't good enough. None of these are good enough. They all suck. Different files for metadata and instructions increases complexity, particularly when the two interact. If you've got like a version-dependent path, your JSON, your CMake have to talk to each other. No good. And then writing a custom language comes with a huge maintenance burden, so that's out of the question for a small team. There's 4 of us. We can't maintain our own language. And then note that languages are a lot like partners. Initially, it might seem like a great idea to have 2 or 3 or 4 of them, but it does actually get pretty complex with their interaction. So ideally, your backend and your packages are in a unified existing, so one that you didn't make up, like NIM or Nix language. But such a language needs to be able to do quite a few things. You want to be able to execute from text. You don't want to have to ship compiled binaries to update your package files to then update your packages. Self-contained commutable dependencies, we went over this earlier. And then you do actually want sustained or total backwards compatibility. Again, for the dependency bootstrapping issue, if you have to rewrite your package manager every 3 weeks, you wrote it in Lua, no good. This is not a comprehensive list, but you get the idea. However, these requirements are absolutely satisfiable. In fact, there is one language that does all this and more that is unequivocally the best tool for the job. CoffeeScript. So, CoffeeScript is, wrong slide. Ruby, here we go. Ruby is a high-level, interpreted, object-oriented, garbage-collected language with a dynamic typing or optional static typing, a powerful standard library, simple, expressive syntax, and it's reflective in a good way, not Java, in a good way. There is more. It is optimized for programmer happiness. It's actually faster than inline assembly. It's able to trivially recover lost float precision. It's used at NASA for mission-critical software. I hear that the Moonlander actually runs on Ruby. It inspired all of the good bits of Rust. So you go to the Rust documentation when it says inspired by, under all the good bits, it actually says Ruby. And so much more. We don't have time to get into all of this, but for now, Ruby is the best language of all time, and the bits that are important is the high-level, object-oriented, good syntax, good library, and good reflection. What do those look like? So I've talked a lot about languages in theory and practice, splitting up. To explore the pros and cons of various approaches, let's take a look at the same package, FreeBSD, don't know how to pronounce that, across multiple distributions. It will be Debian, Fedora, Arch, and then Chromebrew. Some things to keep in mind about it as we go on. It is a dual autotool/Mason build system. It has no dependencies. It has built-in unit tests, and it's hosted on GitHub. It has release tarballs and git tag releases. Let's start with Debian. This is Debian's control file. Well, no, it's a third Debian's control file. I couldn't fit it all on screen. The important bits here, there's the home page. That's about it. Oh, the architecture. And then you can see it's split up into multiple packages. There's a description, another description, 2 links to the same thing, dependencies, We said earlier it doesn't have any dependencies, so good job, Debian, for finding some. Maintainer, uploaders, the name again, priority, section. This does go on, as I said, for 3 more slides, but I didn't put it in there because we got places to be. More Debian. The license file. Just the entire license file. Licensed 1, 2, 3 times. The name again. The license name again. More copyright, and then a copy of the license, including a link to another copy of the license. The only relevant bit here is LGPL 2.1 plus, but whatever. Debian license separate file. We continue on. This is the changelog. It's not the full changelog. Again, the changelog goes for about 1,000 lines. The only reason I put this in here is because the only place the version is stored for a Debian package file is in the changelog. That right there is the way you get the version. You post the latest bit of the changelog. So if this isn't in here, you don't know about the version of your package. Continuing on. This is the actual build bit. This is the instructional information here. You notice it's a make file, but it's not really a normal make file. We said this is a AutoTools or Mason build system. You don't see AutoTools here. All you see is DH auto configure. That is a Debian wrapper for a bunch of different build systems. And the only relevant bits here, it configures it, and it passes enable malloc and enable static. Both of these flags are on by default, but that's cool. Pop off Debian. Then the unit tests. I did say FreeBSD has its own unit tests. Debian does not care. Doesn't even run FreeBSD's unit tests. You can see here, no make test or no Mason test or anything. It has its own tests. All this test does is, I mean, you can see it. They put the headers in the package config file in the right place. Great test, Debian. Fedora. This is the RPM spec file. And you can see it's already quite a bit more compact than Debian. You have a summary, a name, a version, a fake version, a URL, the source, the license. License is 1 line. Huge improvements. More dependencies. Again, this program has no dependencies. Good job, Fedora. And you can see it's determining what build system to use based on the version of Red Hat Enterprise Linux it's using. Then you've got the description, and then another description, and then another name, because they split up in 2 packages. And you've got the very beginning of the build here, auto-reconf-i, or auto-setup. It continues. It deletes some files from the archive. Great, good for it. And then you got the build. It's got like 5 different versions. So you've got the RHEL version, the RHEL 5 version, RHEL on PowerPC, other PowerPC. The only bits that are relevant here are, again, Mason, Mason build, or configure and make. All of this could be like 2 lines if RPM spec was good, but it's not. And then you have the make test, make check, you've got the test here. Fedora uses FreeBSD's built-in tests because it's not stupid like Debian. We continue. The install. Pretty simple. Make, dester, install, or Mason install. Then does LD config stuff. This sucks for everyone. Removes the LD config of its own LD config. And then you can see it splits it up into its own files here. Again, regular and then devil. Ooh, mood lighting. And then you got a bit of a changelog. Again, this is not the full changelog because the file here goes for 392 lines.
I'm sorry, this was a bad. I was like, can we turn off the floodlights to make the slides more visible because projectors are terrible at dark.
I liked it in the dark. Anyways.
It ruined the video quality though.
Oh, it was alright.
Arch.
Okay.
This is the package build file, bash script. Again, we're getting down to business here. Name, version, fake version, description, URL, architecture, license. That's the wrong license, but that's fine. Dependencies, more dependencies, the name of the library, the commit hash of that commit, and then an empty line that shouldn't be there if PKG builds were better. This doesn't need to be here. Again, the relevant bits here, Mason configure, Mason test, Mason install, Vim configuration options. Yay. That should definitely be there and not in your editor config. This is already more compact than Fedora and way more compact than Debian because it only supports one option. It does Mason and doesn't do any PowerPC nonsense. It does have an entire 3 lines for changing directories, but anyways, this is just one file, so it's pretty good. And finally, we get to Chromebrew. The first thing you will notice, this is 12-point font. 9-point font, 12-point font. It's a smaller package file. And we get down to business again. Description, homepage, version, only one version, and it's the right version. License, compatibility, source URL, the Git hashtag, and then this is only here, that's the binary download hashes. Those are only there because we bundle everything into one file. If you want to do a fair comparison, you would delete these because these are stored server side for everything else, but we seem to be doing fine without a fair comparison. Then we have our Mason options here. We disable documentation, and then we run tests. Just one line, run tests. You will also notice, where is the Mason build? Where is the Mason configure? Where is the Mason install? Up there. Ruby object-oriented. This is a Mason subclass of the package class, and that wraps all the boilerplate for us. So we're down to like 20 lines here. So all the distributions, they're packaging the same package, same file, but there are a number of key differences. Debian splits it up into several different packages, then splits those packages into several different files. It carries its own copy of license and uses its own test files. Fedora, Arch, and Chromebrew, same general idea. Fedora supports both build systems and does more conditional configuration, and it's much larger as a result. It's, again, 3 slides. Arch and Chromebrew were basically the same. You see, basically the same, but Chromebrew skips the Mason boilerplate with the Mason subclass, and it's much smaller as a result. Also, you can notice that there's no equal signs there. That's for some package-specific metaprogramming. Most Ruby has equal signs. So some of the differences are technical. Chromebrew can create a Mason subclass of the package class because Chromebrew package files are just Ruby files, and Ruby has great ROP. Arch can't do this because their files are Bash files. Bash does not have OOP, as far as I know. In this case, both Arch and Chromebrew, we're trying to do the same thing. We're just better. But some of them are philosophical. So we don't have a changelog in the package file like Fedora and Debian because we're hosted on Git, and a changelog is just a duplication of Git history. We don't have local tests because upstream has tests. Tests are good enough. We don't have a license file because we give the name of the license, and it's the same license corresponding to the name everywhere. This works. This is a good jumping off point to a bit of an organizational overview. It's an explanation of why we make these decisions. As described earlier, Chromebrew is run by a small team. On a good day, we average 3 maintainers total, just because some of us have lives and are asleep. But we maintain 2,482 packages, meaning each one of us, like me, is responsible for about 827 packages. That's not to mention dealing with the infrastructure, the backend, or users. 827 packages is a lot. For comparison, Debian developers, seen here, handle a little over 4 packages each. So as we continue, just keep that in mind. Keep in mind that disparity and the role it plays in the decisions we make when it comes to how we solve problems. We are managing a lot more packages than they are. Oh, a minor disclaimer. We actually only maintain 2,481 packages. Jason Pratt, seen here, has taken it upon himself to maintain the Terraform package since 2022. On the right, here's one of the 40 pull requests he's done as part of that. He's always there. Just 41 every single time. Great guy. Let's take a look at 3 major problems package managers face and compare the different approaches taken by Debian and Chromebrew and illustrate these with specific examples. So we're going to talk about adding a package. We're going to use libversion as an example. We're going to talk about updating a package, Mesa as an example, and then fixing or patching a bug in a package. We will use libedit as an example. Adding a package. I didn't want to know what time it was anyway. That's fine. In Chromebrew, you make a pull request. In Debian, first, follow steps 15.4.1 to 15.4.2.5 of the Debian Administrator's Handbook. Join an internal Debian team. Create an account on mentors.debian.net. Read the 89-page Debian packaging tutorial, in addition to the handbook. Upload the package on mentors.debian.net. Ask the Debian Mentors mailing list for a sponsor. File a RFS bug against the sponsorship request's pseudo package. It keeps going. I just didn't have time to put it all on here. So let's take a look at the process of adding a package to Chromebrew. Libversion is an example. First, you make the package. Seen here. Description, homepage, version, license, compatibility, source URL, Git hashtag, Then to CMake, so we just put CMake, run tests, done. Again, this bit handled automatically. This took me about 10 minutes to do, and most of that was just finding the home page, license delays version, and then checking, oh yeah, this is CMake, and then put it all in the package file. I then used the build package workflow on our CI, took 15 seconds to fill out our branch name, which was libversion, and then I waited 10 minutes for it to be built, and changed to be pushed, and the PR was made automatically. PR, seen here. That was made automatically, and approved, reviewed, and merged. It took a little under 2 hours for this to get reviewed and merged, and that's longer than usual because it had a special case. For comparison, the first Chromebrew package I ever made, libbitesize, took me about an hour to make, and then took a few days to get reviewed and merged. I was about 15 at the time, and I have clearly gotten faster and better as I've gotten older, but even for a literal child, contributing to Chromebrew was pretty easy. Again, 15. I was like in the middle of history class. This slide was supposed to contain images of me adding libversion to Debian. You may notice no images. The barrier to entry to doing this was high enough, the 89-page tutorial, that it was easier to build this package from source every single time we run our CI than it was to add to Debian. As I said earlier, Chromebrew, simple enough to contribute to that a child could be a maintainer. And in fact, many are. The project was started by a child, and there have always been children on the core team. Right now, there's only one because I got old and washed up. But it's like, meanwhile, as an adult with several years of programming and package management experience, I couldn't even figure out where to start after trying for 3 days. I didn't get to I read the 89-page handbook. I filed the mailing list bug, whatever. Again, am I personally stupid? Yes, of course. But does that excuse Debian's barrier to entry? Probably not. Updating the package. In Chromebrew, you update the package version in the file, you run the build workflow, and then you or someone merges the generated pull request. Now, note that the first and second steps are automatically done. We have CI that automatically does this for most packages, so you only have to merge the pull request. But in worst case scenario, you have to edit the package version in the file, click run build, and then merge. Debian, not that bad. Update the package version in the changelog. Rebase a patch quilt. Locally build the new version of the package. Sign the binary, submit the build package to the upload queue, and then accept the upload in the relevant branch. Let's take a look at what this looks like for Chromebrew for Mesa. Step 1, update the package version. Seen here. A little small, but you get the idea. A one-line change, you change 2 numbers. Step 2, run the build workflow. Build workflow, seen here. You type in update Mesa or whatever you name your branch on, and then all this is set up by default, and you click run workflow. The pull request is automatically generated. Pull request, seen here. That's a pull request. This was 3 days ago by now, but you get the point. And then you review and approve the pull request. Approval, seen here. We have auto merge set up. So you just approve it, and then you're good. Debian. Step 1, update the package version in the changelog. So, update the package version. Again, it's not that bad. This isn't actually the right update because there were 3 different updates for this that I couldn't find the right one for, but pretty similar. You change a few lines. You build the new package version. This is an excerpt from one of the 3 Debian manuals on how to build a package, but it's just one command, usually. dbkj build package us uc, and then you install the right dependencies. Other architecture will be built automatically. So if you're on x86-64, the ARM or the PowerPC or the Spark versions will all be built automatically when you upload it to the build queue. But you still got to do your local version yourself. We continue. Step 3, you sign the build package. Just, deb sign, then use the deb sign command. Not that bad. I mean, you do need the GPG key, but whatever. You upload the build package. Again, excerpts, you make your own dupload config file or dput, but let's go with dupload for now. You read the manual to make your config file, you set the default host, and then you upload the file. Not that bad. Keeps going. You just review and accept the upload in the relevant build branch. That's what this looks like here. Mailing list, obviously, changelog, checksums, distribution, urgency, source, format, maintainer, Debian, X, Strikeforce. Fixing or packaging a bug in a package. In Chromebrew, you open a pull request, you fix the issue upstream. Then this part is critical. You sit and you wait for the pull request to be merged. Then you update the package. This doesn't work if upstream is inactive. And an inactive upstream is a massive pain for everyone. But stay tuned for Project Waterfall, which will alleviate this. I'm going to get some water to alleviate my thirst. Where did I put my water bottle? Aha. That should come across great in the audio. Sorry about that. Continuing on, Debian. You patch the issue locally. You add the patch to the patch quilt. You fill out the attached patch template in accordance with the patch tagging guidelines, version 3, 2024. You rebuild the package with the patch, and then you rebase the patch with each update. Now, it does say, and again, one of the 2 separate Debian patching guidelines I could find, that if possible, you do submit the patch upstream. Let's see how that actually turns out. Chromebrew. Step 1. Open a pull request to fix the issue upstream. This is actually not a pull request. This is an email. I needed an email instead. This is for, again, libedit. They didn't, or edit line. They didn't have a GitHub, and so email. Wait for the issue to be fixed upstream. Waiting, seen here. Fixed upstream, seen here. I just say there's an issue, they fix it. Step 3, update the package. We did go over this earlier. Again, trivial, you know. I think libedit was actually automatically updated after I did this, so that's kind of cool. Debian. Step 1, add the patch to the patch quilt. Just, you know, change log, the patch. The actual patch here is a little under 2,000 lines, so I couldn't fit that on the slides. But, you know, just quick, easy thing, 2,000 lines. You rebase the patch with each update. Definitely happening here. 2018, rebase the patch. 2021, rebase. This continues down to about 2004, which I couldn't fit on the slides here. But, again, 2,000 line patch, rebased for about 20 years. Good for you, Debian. Step 3, you submit the patch upstream, right? This is the Debian libedit package. Note that it is saying you should submit these 6 patches upstream. So that's cool, right? Last update 2025, but don't worry, they submit the patches upstream. Right? See here, patches, not submitted upstream. Famously, not upstream. Big no, right there. A quick note. This bug in libedit was introduced in 2004. 2004. They had 20 years to submit upstream. But it's not just Debian. 65 different distributions package libedit. Out of the 30 I checked, 10 have patches or workarounds for this bug. Assuming that ratio roughly holds, this bug has existed for around 400 collective years. In all that time, none of them fought to upstream the fix. But when I say Chromebrew, we don't have the luxury of inefficiency, I'm talking about this. 2,000 line patch, 400 years. I wrote an email, took 10 minutes. Again, middle of history class, email, 10 minutes. It's not that hard. In conclusion, I'm going too fast. Anyways, in conclusion, patch management is a lot of work. Chromebrew is successful despite a small team because we minimize the work. It includes a simpler package format, which we covered earlier, Debian, 8 slides, Chromebrew, 1 slide, a simpler development process, 1 pull request, no 89-page manual, and a strong focus on upstream collaboration. For example, when a bug has existed for 20 years, we fix the bug. We fix the bug. We don't stand around going, we should upstream this, right? We should upstream this. We should probably upstream this. It's been 20 years. Should we upstream this? No, we shouldn't. Apparently not. Strong upstream collaboration. Bonus slides. This is just a random collection of slides I lying around that didn't fit nicely into the narrative. And I'll see how many I can get through as time allows. I can't count. How much time do I have? Plenty. Dependency question. The dependency question. One of the main problems in package management is dependencies. You know, you've got your version, your ABI breaks, backwards, forwards compatibility, etc. Linus Torvalds said, that's what I fundamentally really think needs to change for Linux to work on the desktop. He talked about how Valve was going to solve it. Spoiler alert, Valve didn't solve it. Common Valve L. This problem does manifest itself differently depending on your language, your ecosystem, the availability of source, and each solution is a trade-off between compatibility and efficiency. Let's take a look now at some of those solutions arranged nicely in a table. Table, seen here. So, first up, we have doing the work. This is what a normal package manager does. You just install the dependencies system-wide, and if they break, you fix them. You get ABI compatibility. Is it easy? No. Is it efficient? Yes. Is it compatible? Does it work? I mean, most of the time. Is it scalable? Yes. Who does this? Debian, Chromebrew, Fedora, Homebrew, Alpine, more people. Static linking. This is when you just embed like most of the library you're using into each copy of the package file. Is this easy? Yes. You're not doing, get back there. Is it easy? Yes. You're doing basically a little work. Is it efficient? Not really, because you're copying every single library into each package and duplicate across the entire system. Is it compatible? Yes, because you're not doing any work. Is it scalable? Again, not really, because it's not that efficient. Who does this? Rust does this. Go Rust. What distributions do this? None. Oasis, Stolly, they don't exist, and they're not real, and they're really small. Basically, no one does static linking on a large scale. But library vendoring. Is this easy? Yes. Is it efficient? No. This is when you copy every single dynamic library your package uses into a folder and call that sandboxing. Is it compatible? Yes, because you copy every single library. Here's the thing. Static linking, right? You take only the bits of the library you need. So let's say you use FFmpeg only to convert images. When you statically link, you only take the image code. When you library vendor, you take the entirety of FFmpeg every single time. So if I have a VLC regular package that has FFmpeg, and I have a statically linked one, the statically linked one will be a little bigger. If I have a library vendored one, that will use the entire concept of FFmpeg. Is it compatible? Yes. Is it scalable? No, it is not scalable. Why do you think there are no distributions based entirely around Snap or AppImage or Flatpak? Despite Fedora's best attempts, you can't do everything in Flatpak. Also, if you scale Flatpak up to a full system that is a regular package manager again, but except you just copy every dependency like 40 times. Steam does this as well. In the talk earlier, this one, good talk, watch it if you want. Linus Torvald said, I think Valve will solve this because they're going to statically link everything. However, he is kind of stupid from time to time, and you can't statically link if you don't have the source code. You don't have the source code to compile proprietary games. So Steam does library vendoring. Steam Runtime is a copy of Debian. Your Steam bundles about 6 copies of Debian with it. Did you know? Fun fact. Now, we've got a very, very good option coming up. Not doing the work. Is this easy? Yes. Is it efficient? No. Is it compatible? No. Is it scalable? No. Who does it? JavaScript and Python. Does JavaScript actually vendor dependencies? Sometimes. Does Python? No. Again, not doing the work is very tempting because you don't have to think about it. Python dependency hell, as you talked about earlier, is mostly exclusive to JavaScript and Python. You don't talk about dependency hell.
And that occasionally.
Occasionally. But again, is it compatible? Sometimes. Is this compatible? No. Never. Because when you install a Python package, as you know, and as you know, it doesn't work, as I know, because Python doesn't do the work. However, we've got one very nice option here. Being better. That should be a check. Oops. Being better. Is it easy? Yes. Is it efficient? Yes. Is it compatible? Yes. Is it scalable? Yes. Who does it? Ruby and probably Crystal. When you install a Ruby package or you use a Ruby bundle, every dependency is installed system-wide. And the bundle just takes those copies system-wide. Imagine if you had a virtual environment without the virtual environment and your packages just worked because your language is better. Wouldn't that be neat? Anyways, oh, a reminder, everyone in the team is volunteering in their spare time. I'm a full-time uni student, and I have 2 full-time jobs, or 2 part-time jobs. And then Ed Veal, Uber hacker, he's a professional programmer by trade. Sadaru, he's a doctor with more doctor things there. I think that's mastery in public health. But everyone still works incredibly hard. You can see here, that's working incredibly hard. Almost all of these are package updates or pull request reviews. Like, I don't get how they fit in the time. Is Sadaru like scalpel, pull request, scissors? I don't get it. He's got 2 kids. How did he fit in the time? I don't know. But we all work incredibly hard. Again, Debian developers maintain 4 packages. We maintain 827. Are we working 200 times harder than them? No, because we minimize the work. Are we working 50 times harder than them? I mean, yeah, probably. This is evident by the fact that Chromebrew has Ruby 3.4. Debian doesn't. Anyways, this is a minor thing. Rust not having dynamic linking is really bad. Really bad. Seen here. That's bad for binary sizes because, as I covered earlier, every Rust program includes every copy of every dependency it uses. So here's an example. Fish, great shell, used to be written in C++. It was 8.76 megabytes. Now that you write it in Rust, it is 21.4 megabytes. That is not good. That's more than a doubling in size. You can't do that to all of your packages. So before you rewrite it in Rust, why don't you fix Rust? It's bad for compilation times because every Rust program builds its own copy of every dependency it uses. For those of you who've used NPM, you know when you type npm install and it installs 700 packages, 84 looking for funding, 3 maintainers need a hug, added 14 security vulnerabilities. That's really bad. But because JavaScript is interpreted, you don't pay the price for that. When Cargo does that, you build all 700 of those packages from source every single time. I know. Chromebrew does it. It sucks. Debian does it. It sucks. Debian has complained about how bad it is to build Rust packages because you don't get any of the benefits of dynamic linking, which we figured out is a good thing to do in like the 1950s. Catch up, Rust. Anyways, don't use makefiles. Talking to you specifically. And anyone else thinking of using makefiles, don't do that.
Can you tell us DCC as well?
Don't do that. Makefiles lack standardization, which means every package, like yours and yours, that uses a makefile requires bespoke arguments and configuration. There's a reason, Chromebrew, we have package subclasses for Mason, AutoTools, CMake, QMake, and the rest, but nothing for makefiles. Nobody does. Debian doesn't, Chromebrew doesn't, because the lack of standardization makes this impossible. So the average CMake package doesn't include any additional work from Chromebrew. You saw that with libversion. The average makefile package, no matter what, does, because we don't know how you treat dester or prefix. Do you swap around dester and prefix? Plenty of people do this. Don't do that. If you use a makefile, come see me after the presentation. This is another thing. You don't need to build on Docker. See here, Krita, which thinks it needs to build on Docker. Unsupported regular building. Your package is not so complicated that the only way to build it is in Docker. It's just not. By assuming that it is, you make it harder for the distributions actually packaging it, doing the work to do it properly. Building packages is hard enough without upstream going, actually, our software is uniquely complex, and so we're going to give up on building it normally. Seen here, giving up. It's not that deep. You don't need Docker. We package Krita without Docker. They can manage, but it's harder because Krita assumes you have Docker. Blender is even worse. Similarly, don't vendor your dependencies. You don't need to do it. Seen here, this is shader C from Google. An open issue to sanitize the build system for packages. 6 people say, yep, you should do that. Another guy says, yes, this is a nightmare. Spiderweb dependencies in poor design. Seen here, maintainer. The cause of the complexity is that shader C is built in various configurations. Also, the current setup just works. Shush. No. Everyone else has managed this for the past 20 years. I cannot emphasize enough that your problem is not unique and it can be solved normally. Everyone else manages to use their dependencies normally, not clone them in and build them manually every single time. Because now Chromebrew has to ship 3 copies of Vulkan tools because shader C can't get... I don't like this. Don't do this. Don't vendor your depths, man. Don't vendor your depths. Be a good OSS citizen. Don't use a makefile. Don't hardcode your installation prefix. Probably one of you. Don't do that. Don't use a non-standard build process. Don't be Krita. Don't be Blender. Don't vendor your own dependencies. Really, don't vendor your own dependencies. Especially if you don't even support using the system ones, like shader C. Like, Dolphin uses its own dependencies by default, but it supports system versions. That's good enough. We can package it normally. Don't use scons. Just don't use it. It's not very good. It's pretty bad. Doesn't let you customize installation directories. Don't use it. None of you have heard of SCons, but that's fine. Some slides that were cut for time. The image over there in the top right, that is the logos of Snap, AppImage, and Flatpak. Too many cooks in the kitchen, spoiling RPM. Other things that were cut for time, more complicated packages, more complicated package management backend, a detailed explanation of static linking versus dynamic lib bundling, a live demo of me updating the Chromebrew package. The package I was planning to demo got automatically updated last night while I wasn't looking. We're too good. And then why NixOS's maintenance burden grows exponentially and why it's actually not good. Is that all? That is all. Do we have time for Q&A or perhaps a live demo? Yikes. Live demo, Q&A. You've got the mic. Oh, clap. Clap.
Question.
In 2521, don't you use make files?
Yes. If you see all the way back here, notably, 2521 is nowhere to be seen in the solving problems section. That's unrelated, but I just want to point that out. In 2521, we use make files, but you never ship anything making 2521 to the outside world because it's, it's useless. It's solving problems. It's for children and toys. But yes, they should be using anything else in 2521. Well, they shouldn't be doing 2521 full stop. Download 2521. Does that answer your question?
Yeah.
CMake.
Yes, but that's okay, not good.
Mason.
I haven't looked very much into it, but...
It gets the job done.
Okay.
In my 827 packages of experience.
Can you quickly go back to the very last slide again, the slides cut for time?
Yes.
Yeah, why is NixOS's maintenance burden growing exponentially, and why is that actually not good? So, like, you told me this earlier, but I think it'd be interesting for others.
So as you said earlier, and as I've experienced, NixOS keeps every single version of a package. So yes, you can install Gradle 8.8. That's great. But what that means is you have to keep every Gradle from 1 to whatever they use now, and you have to keep that functional. So whenever NixOS adds a new version of the package, that just stays there. It stays there. They do not remove the old version. So Chromebrew, we ship one version of Gradle. NixOS ships 30.
Arguably, the reason I can get the old version of Gradle is because I was literally going back through their Git history, which is
yes.
Cursed.
Not only does their maintenance burden grow exponentially, they don't even distribute it efficiently. Like, you couldn't find that effectively, despite the fact that they did the work to do it. Anyone else, or did that answer your question?
Yeah, answers the question.
Is Chromebrew faster than inline assembly?
Consult the slide. Yes, it does. Seen here, Ruby is faster than inline assembly.
Yeah, you run it with C Ruby though.
Speak for yourself. We may not ship truffle Ruby, but we could. We could.
Sorry, yeah, can you go back to the slide with the trade-offs for the different ways of doing package management?
Yep. Which one?
The one where you compare like doing the work, not doing the work.
Yeah. Dependency management.
Yep. Yeah. I was wondering, you maybe did mention it, but I might have like misunderstood or missed it. Could you go a bit more in depth in like how Ruby and Crystal do this? And what you mean by being better?
I'd be happy to. So when you install a Ruby package, or not, you use gem install system-wide. That works flawlessly. When you're developing something, you use a bundle file, which is a little bit like a requirements.txt or package.json, but it's better because it's written in Ruby. But the key thing here is when you run something, you do bundle install or bundle exec. This installs them system-wide. So there's no node modules. There's no virtual environments. Every package you need is installed system-wide, and that is shared and that is reused. So Ruby doesn't have dependency hell because you can always install the right version of the dependency, and it will always be reused. So it's space efficient, it's easy, it's compatible, it's scalable. And then if you're developing a package, you get bored of the package, you delete it, you do Ruby gem cleanup, and that deletes all the gems that don't have a bundle thing linked to them. Last I checked, pip did not have auto remove. So yikes. But yeah, so basically, it's just better because A, it's Ruby. Please see the blog and the slide. but also because dependencies are global, they are system-wide, they are shared, and they are always compatible. You can install as many as you want next to each other, and they're cleaned up after you're done, if that's what you so choose. So when I work on different versions of Rubocop when I forget to fetch my home directory. So as a result, I have like 6 different versions of Rubocop for development, but they all work. And when I don't need them, I run gem cleanup, and I go down to the 2 I actually need. Yeah, and then I think Crystal does that. I don't know. I haven't checked. They probably do. Crystal does have the thing where it's compiled, which changes things a little bit, but it's not like Rust or anything. All right. Any further questions? It would seem so.
Yeah, one question I do have is in terms of like you've put Python in the not doing the work category, and modern tools like UV in the Python ecosystem, they actually do the whole like deduplicating packages by using a global cache. So although yes, I know there are many options, and most of them are bad as well. Yes, I'm aware, but yeah, the whole deduplication of dependencies thing is something that Python is beginning to do now. So is it specifically that the problem is that those dependencies are not globally installed? And
so the problem is virtual environments. It's a lack of, as you well know, is a lack of actual dependency pinning or hash pinning in requirements.txt. Again, we've been over this. There are a couple of Python options. I'm sure you're all familiar with the XKCD, where there become 15 competing standards. Python, if UV takes over the world and the next time it's presentation, it's just UV, like Ruby or Rust, that's great. But as of right now, as you said, Python is beginning to get good, but it's not. And the first, if you give a data scientist Python, they will use pip to install their package, and they will make their requirements.txt with no dependency pinning and no version pinning. And when you try and run it, your system will blow up. In Ruby, that won't happen. So, yes, the best of Python is nearly as good as Ruby, but it's not you're not using the best of Python. You're using the regular of Python.
So you're essentially saying that my problem is that I'm too good at Python.
I'm saying the problem is that the average Python user is not good enough. If you are better than the average Python user, great. If you can make every other Python user better, even better. But as of now, you deal with the worst, because again, we handle 2,482 or 81 packages. So I've seen every possible worst case scenario. But in Ruby, the worst case scenario is still pretty good. All right.
Thank you very much.